Module 3, Exercise 3, has us dividing up the model with section boxes. This way we can take a larger model, physical model that we're trying to build, like for this instance at a 16th inch scale, and fit it within the print volume of a 3D printer. So we're going to learn how to leverage a section box tool for models larger than your 3D printer volume, use the STL exporter for Revit, and prepare the model for Makerware. When you're working with 3D printing, you're often going to run into the situation where the building that you're working on and the scale that you want to do your model at are not going to work for the 3D printer that you're sending the fabricated Revit model to. In this instance, we're sending this to a Rep 2, which has a fairly large build space, but the overall volume, if it does fit, it's going to be very, very close. So there are some techniques that we've developed that simply help you use existing Revit tools to divide the model up into pieces for easier 3D printing. And we've discovered that there are also some added benefits in doing that as well. So one of the first things that we need to do is develop a new sheet that we've called the Rep 2, simply to get an understanding of what our build volume is like at our given scale inside of Revit. So this is approximately 11 inch by 6 inch sheet, which is about the build space of a Rep 2. And I'm going to take my view, my 16th inch view, and place it on the sheet to understand about how well this model is going to fit on the Rep 2 build platform. So we're going to look at this view, which has its scale set to a 16th of an inch. And I'm simply going to drag and drop that view right into my build platform. So you can see it's going to fit, but it's really close. And one of the things that I've learned in 3D printing the last couple of years is pushing the overall build volume all the way edge to edge is, well, it's not a surefire way to create a failure in the print, but it certainly increases the probability. The longer print space is going to have more of a potential to warp. And if I cut this model into two pieces, I get this added feature of being able to hold up two pieces of the model and see the interior spaces at eye level. So it's a trick that you don't always have to do, for sure, but it's a trick that actually gives you some added benefits. It's also something that when we use the section box to divide the model up, will allow us to build multi-stories or much larger spaces than we could possibly fit on a 3D printer like a Rep 2 in a single pass. So the technique is a pretty simple thing to do, and it's going to utilize the grips on the outer edge of the section box to build common lines across our build that we can put back together later. Essentially, on this particular model, we'll be printing this in two pieces, the east and the west. So we're going to turn on the section box tool, and let's begin by setting up the the west edge of this model. And where I place this cut line with the section box is going to be very important as well. I want to make sure that it's in a logical location and that we're not leaving any overhanging edges, things like that, things that might be difficult to print. So again, I'm using the grips and sliding them to begin setting up this individual model that I'm going to export. If I have an overhanging edge like this, I know that's going to be a problem. The Rep 2 and most 3D printers that are using FDM extrusion won't have any problem doing short spans, but an edge like that, that's sort of a naked edge without any supports underneath it, are definitely going to create problems. You also want to look for anything that might be an odd angle like that, this edge of this wall in terms of how it's being cut off. Try and eliminate those as well, simply to get pieces that are going to fit together really, really nicely and really cleanly. So that looks really good in terms of setting up the west edge. And what we want to do next is manipulate the lower edge of the section box to cut off any pieces that are hanging underneath. And we'll have to print those out as separate elements later to work with the topography. So I'm going to bring the bottom edge of the section box just to the inside of that floor system. That's just a simple 12-inch generic floor. And that way I know the bottom edge is always going to work and print perfectly flat onto the build platform on my 3D printer. So I've already got a naming convention, and again I like to use a ZZ prefix to put these all towards the end of my model in my viewfinder, or in my project browser rather. So I'm duplicating my view, and I'm simply going to name the next piece East. I always want to maintain these views. I don't want to lose one of my views that I'm creating. I want to be able to go back to them. And what I'm doing next is I'm sliding the section box all the way down to where I essentially have a two-dimensional section. I'm deselecting and reselecting the section box, and now I'm going to pull that section box out to the east. And what that's done is it's given me a common line between these two views, which are going to become two versions of my physical model, an east and a west edge, that share perfectly that line right across the middle of the model. In evaluating what I have left, I'm noticing there's one more thing that we need to make sure that's clear in the process. Revit, by default, does not have an STL exporter in the system. So we need to install that as an add-in. And it's on Autodesk's website, and it's on the website called the Autodesk Exchange Apps. And what we need to do, if you need to find it, simply type in Revit XTL export and the version of Revit you're using, 2016. And that's going to give you in the add-ins, once you run the install file, the STL exporter for Revit. So I'm simply going to launch that, give my file a name, Museum East, and save. Let's go back to the other view, and again you can see that common edge that we've built, export, save, and Museum West. And you know, it always seems like there is one more thing. So one more thing. As I was looking at this model, just as I was exporting, I noticed there is another edge that's overhanging right here on the piece of the wall that's sort of wrapping down and around. And I know that's going to create a little bit of a problem there because there's nothing for that to support onto. So, real simple fix for that. I'm going to build a simple generic model that's going to act as my support for that corner. So I'm going to go to Components, Model in Place, Generic Model, and I'm going to trace out a little column right here. And I'll hide this in all my views, but I'll keep it as part of my 3D model. And I'm going to go slightly larger than 1 foot by 1 foot in my dimensions. I know this will be slightly larger than a 1/16 of an inch column. So I'll accept that profile. And then I'll pull that up to the bottom of that form on the building. And I know when that prints, really simply, once I pull that out of the printer, I'll just snap it off. So I'm going to pull the bottom underneath the section box so it is cut off perfectly at the same elevation in terms of the base as everything around it. And that should take care of that overhanging piece, other than the fact that I need to export this again as an STL file. So let's go back to the add-ins one more time. STL export for Revit. And we'll overwrite that former Museum East file. Now that we have this done, we'll go into the next video where we'll actually open up these files in Makerware and prepare them for 3D printing. From exercise 3, we were able to use the section box tool to divide a model into smaller pieces that fit together perfectly after printing. We were able to export directly from Revit with the STL exporter, and we're preparing models ready for makerware and 3D printing.